Hello everyone, in this video we will learn all about ratio and proportionality. Now, given this table on the attendance of students, so we have here the number of boys, the number of girls, total number who are present, those are absent, and of course the total number of students. First question, what is the ratio of the number of boys to girls who are present? In this case, we have here 19:20. Next, what is the ratio of the number of students who are absent to the total number of students? In this case, we have here 7 and 46 is the total number of students. Now, when you say ratio, it is a comparison of two numbers with the same unit or different unit of the same kind. Now, proportions states that two ratios are equal. So, for example, we have here 1/3 is equal to 2/6. This is an example of proportions. Next, rope's length and weight are in proportion. So in this case, we have here 20 meters is to 1 kilogram, as to 40 meters is to 2 kilograms. Next, when shapes are in proportion, the relative sizes are also the same. So just like this, so we have here 10/20 is equal to 15/30. Now, there are terminologies of proportions. The first and the last terms of proportions are considered as the extremes, while the second and the third are called the means. So take note, proportions can be written this way or it could be written this way. So again, A and D are the extremes and B or C are considered as the means. Now, another term is mean proportional, or it is geometric mean. Now, in the proportion A is to X is equal to X is to B, X is the mean proportional between A and B. And to get the geometric mean, it's basically the square root of the two proportionals. So, again, B is called the third proportional to A and X. So, for example, we have here 2:8 is equal to 8 is to 32. So, when you say geometric mean, so the means are equal. So, how is it obtained? So, we have here 2 and 32. So, that would be 64. Get the square root, that would be 8. So, again, 8 is the mean proportional and 32 is considered as the third proportional. So take note of this. Okay, now given this example, find the geometric mean between each set of numbers. So we have here 9 and 5. So that would be the square root of 45, or that would be 3 square root of 5. Another. For 18 and 32, so multiplying them, we'll get 36, get the root, so that would be 6. Okay, now there are properties of proportion. So again, if we're given A is to B is equal to C is to D, so we can write it in the form A over B is equal to C over D. Now the first is the cross multiplication property that states the product of the means is equal to the product of the extremes. So with that, cross multiplying, so we'll get AD, and we have here BC. Next, we have the inverse property. So in here, the reciprocals of the two ratios are also equal. So again, AB, reverse it, we have BA, and the other side will have DC. Okay, another. We have here the alternation property. So the means may be interchanged and the extremes may be interchanged as well. So in this case, the means are interchanged. So we can have it as A over C is equal to B over D. So again, the means here are interchanged. Next, we have here addition property. So the denominator of each ratio may be added or subtracted from its corresponding numerator. So again, originally we have AB is equal to CD. So we can have it as A plus B over b. It is just the same with c plus d over t. Okay, another. We have here the numerator-denominator addition property. So it states that the ratio of the sum of the numerators and the sum of the denominators is equivalent to each of the equal ratios. So again, originally we have this, so we can add a plus c is equal to b plus d is equal to a constant k. So take note of that. Okay, so let's have this. Simplify the ratio of 2 feet into inches. So take note, 1 foot is 12 inches. So with that, 2 feet would be 24 inches. So writing it, so 1 over 12 is just the same with 2 over 24. Okay, another. Divide 1,000 pesos with a ratio of 5:3:2. Now, given this, so we have here 5 plus 3 plus 2, so that would be 10 parts. So 1,000 divided into 10 parts, so we have here 100 each part. So if you have 5 parts, so that would be 500. So 3 parts is 300, and the last 2 parts is 200. So these are the corresponding denomination of 1,000 with the ratio 5:3:2. Okay, another. What is the value of n in the proportion 4:n is equal to 3:5? So writing it in this way, we will get this. So cross multiplying, so 20 equals 3n, or n is 20 over 3. Okay, another. Solve the proportion given. So again, rewriting it, we will have it this way. Cross multiplying, we will get this. And simplifying, we will have x as 5. Okay, another. What is the mean proportion of 3 and 12? So again, so to do this, we can have it 3 over x is equal to x over 12. Or we can simply get the multiply, then get the square root. So getting the square root to both sides, so therefore our mean proportion here, or geometric mean, is 6. Okay. Now, find the third proportional of 2 and 4. So, again, rewriting it, we will have 2 over 4 is equal to 4 over x. So, 2 is the first proportion, and 4 is the geometric mean. So, simplifying, we will have x as 8. Okay, another. Find the fourth proportional to 3, 2, and 9. So, rewriting it, we will have 3 over 2 is equal to 9 over x. So simplifying, we will get x as 6. Okay, next. Find the values of x and y in the proportion 2:3:4 is equal to x:y:6. Now to do this, solving for x, so we have here 2 over x is equal to 4 over 6. So simplifying, our x is 3. Now to solve for y, that would be 3 over y is equal to 4 over 6. So cross multiplying, we'll get 18:4y, and simplifying further, our y is 18 over 4, or that could be 9/2. Okay, next, let's have this. The length, width, and height of a box for a toy are in the ratio 7:3:2. A larger version of the toy requires a box with a width of 10 inches. What must be the length and height of the required box? So given this, let's solve for the length first. So our proportion here would be 7 is to the length is equal to 3 is to 10 inches. So with this, you cross multiply, and simplifying, our length would be 70 over 3 inches. Okay, now solving for the height. So that would be 2 over the height is equal to 3 over 10. So cross multiplying, so we will have here 20 equals 3h, or h is equal to 20 over 3. Okay, next. Now, divide 48 centimeters into 2 parts such that it will have 3:5 ratio. So 3:5, so that would mean 8 parts all in all. So 48 divided into 8 parts, so 1 part would be 6 centimeters. So 3 parts to that would be 18 centimeters. And the next 5 parts here would be equivalent to 30 cm. So your ratio here would be 3/5 is equal to 18/30. Next, the measures of two supplementary angles are in the ratio 1:2. Find the angle measures. So take note, supplementary angles, the total here is 180 degrees. So the ratio is 1:2. So if one angle is x, the other angle would be 180 degrees minus x. So with that, our ratio here would be x over 180 degrees minus x is equal to 1/2. So cross multiplying, we'll get this, transferring x to the other side. Dividing both sides by 3, we will end up with 60 degrees. So one angle here is 60. And to get the measure of the second angle, that would be 180 degrees minus 60, or that would be 120 degrees. So our ratio here is 1/2 is equal to 60 over 120 degrees. Okay, next. Ratio and proportion in real life. So in one promotions of a gas company, a model car was built to the scale of 1:16. If the model is 15.5 inches long, what is the length of the actual car? So with this, our ratio here would be 1/16 is to 15.5 over x. So cross multiplying, we'll get this. So the length of the actual car is actually 248 inches. Okay, another. A recipe needs 2 1/2 cups of flour for every 3/4 cups of sugar. If 4 cups of flour are used, how much sugar is needed? So again, to make our ratio and proportion here, so we have here 5/2 cup of flour over 3/4 cup of sugar is equal to 4 cups of flour over x. So cross multiplying, you'll get this, 5/2 times x, 5x/2. So 3/4 times 4 will end up with 3. So simplifying further, the value for x here would be 6/5 cups of sugar. So take note of that. Triangle proportionality. Now, let's have this triangle same altitude proportionality. So it states that if two triangles have equal altitudes, then the ratio of their areas is equal to the ratio of their bases. So given this triangle ACB, so it's a right triangle, and we have here CD as an altitude. So with this, the area of triangle ACD is given as 6 centimeters square. Well, the area of triangle BCD is 3 centimeters squared. Now, if A to D is 4 centimeters, what then is B to D? So, with this, we can have this proportion. Area of triangle ACD over area of triangle BCD is equal to AD over BD. Again, this is derived based from this property. So with this, let's substitute. This is 6/3 equals 4 over BD. So simplifying, BD here would be 2 centimeters. Okay, another. We have here triangle same base. So with this, two triangles on the same base and between two parallels are equal in area. So for example, we have here triangle ACB. We also have here triangle ABD, and DC is parallel to AB. So with here, to find the area of triangle ACB, that would be 1/2 of the base, in which the base is AB, times the height, which is H. And to find the area of triangle ADB, that's 1/2 of the base and the height. So with this, we can conclude that the area of triangle ACB is equal to the area of triangle ADB. So take note of this one. Okay, another. The third triangle proportionality would be the basic proportionality theorem. So it states that if a line is parallel to one side of a triangle and intersects the other two sides, then it separates the sides into proportional segments. So for example, we have here triangle ADE. So in here, BC is parallel to DE. So therefore, we can say that AB over BD is equal to AC over CE. Now, making use of the different properties of proportionality, from here, we can derive this one. Cross multiplying this one, we will have AB times CE is equal to BD times AC. So we can derive it from here. So again, we can reverse this. BD over AB. BD over AB is just the same as CE over AC. Okay, another is alternating the numerator or the means or the extreme. So in this case, we have there AB over AC is the same as BD over CE. So take note of this. Okay, next. So that's adding the denominator. So AB plus BD over BD is the same as AC plus CE over CE. Or given this ratio or proportional here, so we can simply add the numerators or simply add the denominators. So let's have an example. So the same triangle. So BC is parallel to DE. So if I have here AB is X and BD is 6, this is 12 and 18. So at this point, find X. So that would be X over 6 is equal to 12 over 18. So simplifying this, the value for X is 4. Okay, another. So the same figure, but this time AB is 4, AC is X, CE is 10, and A to D is 12. So therefore, find AC. So with this, we can have here X over 10 is equal to 4 over 8. So how is 8 obtained? So take note, A to D is 12. This is 4. So remaining here would be 8. So cross multiplying, so that would be 40 over 8. So cancel 8. So the value for X here would be 5. Okay, next. So we have here secondary parts of a triangle. So given this triangle ABC, so we have here AD as the median. So how will you know if it is a median? So a median is a line segment connecting from a vertex to the opposite side of a triangle and bisecting that side. So if this is a median, so it would follow that BD is equal to DC. Okay, another secondary part of a triangle is an altitude. So an altitude is a line segment from a vertex perpendicular to the opposite side. So in here, XE is an altitude, so it would follow that XE is perpendicular to YZ. And the third secondary part of a triangle is an angle bisector. So in here, BD is an angle bisector of angle ABC. So it will follow that angle 1 is congruent to angle 2. So take note, these two angles here, angle 1 and angle 2, they are congruent, but it will not follow that AD is also congruent to DC. So take note of that. Okay, so let's have these different properties here. So I have here CD as a median of this first triangle, and GH here is another median of another triangle. So it will follow here that corresponding medians of similar triangles are proportional to the corresponding sides. So with this, CD is a median of triangle ACB, GH is a median of triangle EGF. So it would follow that CD over GH, their median, is equal to AC over EG, their corresponding sides. And they're also equal to CB is equal to GF is equal to AB over EF. So take note of that. Now, if I'm giving here AC as X, CD as 6, GE as 15, and GH as 9. So let's find X. So to do that, we can have this one. So substituting, so CD is 6 and GH is 9, AC is X, and EG is 15. So cross multiplying, that would be 90 over 9. So therefore, X here would be 10. Okay, another. Okay, now I have here AM as an altitude of triangle ABC. PN is also an altitude of another triangle. So take note, corresponding altitudes of similar triangles are proportional to the corresponding sides. So again, AM is an altitude of triangle BAC and PN is an altitude of triangle QPR. So it would follow that AM over PN is equal to AB over PQ is equal to AC over PR is equal to BC over QR. So for example, so take note, these two triangles here are similar. So if this is 16, this is 4, this is 20, this is X. So making your proportions here, we'll get this. So substituting, so we have 16 over 20 is equal to 4 over X. So cross multiplying, that's 80 over 16. So X here would be 5. Okay, another. Okay, so I have here an angle bisector AD. So take note, the bisector of an angle of a triangle divides the opposite side into segments which are proportional to the adjacent sides. So given this, we can form, again, if AD bisects angle BAC, it would follow that AB over BD is equal to AC over CD. So take note of that. This proportion is based from this property. So now, if I have here X, AB is X, BD is 4, AC is 9, and CD is 3. So making our proportions and substituting. So cross multiplying this one, so that would be 36 over 3, or X would be 12. So take note of that. Okay, so let's have this indirect measurement. So it has been believed that the first person to determine the difficult to obtain heights without the aid of a measuring tool existed even before Christ. The Greek mathematician Thales determined the heights of pyramids in Egypt by the method called shadow reckoning. So let's have a parallel activity to that. So how is shadow reckoning done? So let's have a sample problem. How long is the height of a school flagpole if at a certain time of a day a 6-foot student cast a shadow of 4.5 feet while the length of the shadow cast by the flagpole is 15 feet. So given this, we can make its proportion. So with that, we can have here X over 6 is equal to 15 over 4.5. So with this, you cross multiply, that's 90 over 4.5, or X is 20 feet. So again, we can solve the height of a structure or a building or a tree even if we will not really climb and measure it. No? So it's just by shadow reckoning. So this is how it is done. Okay, next, let's have another example. So a 12-meter fire truck ladder leaning on a 3-meter vertical fence also leans on the vertical wall of a burning building as shown in the figure. How high does the ladder reach? Now with this, we were able to form our triangle here. So getting that, we'll have this one. So we have here 3 meters, this is 12 meters, and here it's 4. So solving for x, we can make its proportion as x over 3 is equal to 12 over 4. So cross multiplying this one, so that would be 36 divided by 4, or x here would be 9 meters. So with that, the ladder reached by 9 meters, no? Even if we will not actually measure it, but we can do ratio and proportion to be able to get its length. So that would be all. Thank you.